Object replication in Azure Storage allows automatic copying of blob data from one container to another, even if they reside in different storage accounts or regions. This feature is designed to support compliance, data distribution, and disaster recovery strategies by ensuring that critical data is consistently copied. Building on previous lessons covering network security, authentication, and redundancy, object replication complements these methods by adding another layer of data protection. It works at the container or blob level, enabling granular control over which objects are replicated. By controlling replication scopes, administrators can tailor data movement to suit performance, cost, or legal requirements, ensuring a more robust and flexible storage solution. Object replication serves multiple purposes within an enterprise scenario. It optimizes data distribution across geographically dispersed teams and services, reducing latency and improving user experiences for applications that rely on frequently accessed data. In addition, it supports compliance requirements by creating read-only copies in different regions or accounts, addressing regulations that require data separation. Disaster recovery and failover planning becomes simpler with consistent, near real-time copies available should primary sources experience disruptions. Furthermore, integrating object replication with other Azure services, such as Azure Data Lake, can streamline analytics workflows across global environments, allowing organizations to harness data while sustaining performance and availability. Before configuring replication, confirm that each storage account involved uses the same Azure Active Directory tenant. Ensure both the source and destination accounts are either general-purpose V2 or blob storage accounts. Access keys or the appropriate RBAC roles, like storage blob data contributor, are required to assign replication policies. Additionally, both accounts must have versioning or soft delete enabled, as this step is crucial for preserving object states in case of accidental or malicious deletion. It is recommended to use a naming convention for containers that clearly identifies their role in replication, making it easier to track where data originates and where it is copied. Replication policies define which objects are copied and their destinations. Administrators set container mappings, specifying the source container and the corresponding target container. They can define filters to include or exclude specific object names or prefixes, allowing precise control over replication scope. Once established, these policies run continuously, comparing the source container's new or updated blobs against existing files in the destination container. If a change or a new object is detected, the system initiates replication. Storage administrators should consider policy conflicts or overlapping rules, as duplication or misconfiguration can lead to confusion, increased costs, and inconsistent replication results. To configure object replication in the Azure portal, navigate to the source storage account and open the Object Replication section. Create or select an existing replication policy. Then designate the source container and link it to the destination account and container. Apply filters if necessary to specify object prefix names. Once saved, Azure validates the configuration, ensuring that the necessary settings, such as soft delete or versioning, are properly enabled. Additionally, the portal provides a visual overview of the replication states, allowing administrators to monitor whether replication is active, pending, or has encountered a conflict that requires resolution. Administrators can also configure object replication using PowerShell. First, install or update the Azure PowerShell module, then authenticate. Use commands like new AZ storage account to create source or destination accounts if needed, ensuring they are properly configured for replication. Next, define your replication policy using new AZ storage object replication policy. Specify the source container, target container, and any filters for object prefixes. For example, you can replicate all blobs starting with log/ while excluding others. Finally, apply the policy to both the source and destination storage accounts. Confirm replication status by checking policy states and verifying that new or modified blobs appear in the target container. For Azure CLI users, replication is achieved through a similar set of steps. Ensure that you have the latest version of the CLI and sign in to your Azure account. Create new storage accounts or verify existing ones with commands like AZ storage account create. Next, define the replication policy with AZ storage account or policy create, specifying the desired source and target containers. You may also incorporate the prefix match parameter for filtering objects by name. Once applied, the policy replicates eligible blobs, and you can track the replication progress with AZ storage account or policy show. This command provides policy details and replication status, helping validate success. Monitoring object replication requires checking multiple status indicators. The Azure portal displays replication health for each policy, highlighting any conflicts. By drilling into specific replication rules, administrators can see how many objects successfully replicated and how many remain pending. Logs in Azure Monitor can also collect and analyze replication events, providing further insight into any failures or delays. Storage analytics can be enabled for source and destination containers to record read, write, and replication data in logs. This visibility allows for incremental improvements in policy design or container organization, ensuring stable operation over time and aligning with compliance requirements. Common replication issues include missing or misconfigured replication policies, which can prevent expected objects from being copied. Check that both source and destination accounts have versioning or soft delete turned on, as replication depends heavily on these features. Conflicts may arise if objects with the same name or different metadata exist in the target container. The Azure portal highlights these conflicts, providing corrective guidance. Network restrictions or firewall rules may also hinder replication if the destination account is not properly permitted. In such cases, review virtual network settings or firewall configurations, ensuring the source and destination are appropriately whitelisted. When configuring object replication, use separate resource groups or naming conventions to distinguish source and destination accounts. This organizational approach reduces confusion and streamlines lifecycle management. Encryption at rest, combined with a strong key management strategy, ensures data remains secure both in transit and at rest. Consider leveraging Azure RBAC to designate fine-grained permissions specifically for replication tasks, limiting who can modify or delete policies. Review replication logs regularly and retain them in a centralized location for audit and compliance. By integrating identity-based authentication, shared access signatures, or key rotation practices, administrators support robust governance and align seamlessly with broader data protection objectives.